movements because of these extrinsic eye muscles. So extrinsic, you have to put that, which means they're on the outside of the eye. The palpebrae is just a name for the eyelids. So there's the palpebrae, the eyelids, top and bottom. So they act like kind of windshield wipers over the eye. We need to blink to keep our eye moist. We need tears to keep our eyes moist. My son is on a medicine, a powerful medicine, maybe you've heard of it, Accutane, for acne, and it dries up everything in your face really bad. So he came upstairs one time and his eyes were blood red. And I thought, oh my gosh, what's wrong with you? And then I just realized this medicine dries out the eye really bad. And if you don't have enough moisture in the eye is like, it's damaged quickly. So we ran out and I bought him some eye drops and he uses them throughout the day and now he's fine, thank goodness. But if a person has like Bell's palsy and the one side of their face is paralyzed, they don't blink and they can't close their eye like they should, and they're at risk for damaging their eye because of it drying out. So we kind of take this blinking for granted. Do you ever have staring contests when you're a kid, right? It's really hard to keep your eyes open because there's a lot of sensory receptors to keep the eye protected and to keep it moist. So we tend to blink our eyes more, you know, when our eyes are drying out. So that's a protective thing. And those are the palpebrae. So there's tears that are produced by this gland on the upper outer edge inside the eye, and it's called the lacrimal gland. So it produces tears over the outside of the eye, and then again our palpebrae act like windshield wipers and distributes those tears over the eye, and then the excess tears drain down the center in the inside corner into the lacrimal duct. So where it first collects here is called the lacrimal sac, and then the nasolacrimal duct leads all the way to the nose. So what happens when someone has, you know, a little bit of tearing from allergies? Do they have a drippy nose at the same time? Oftentimes, yes. Did you ever tear up watching a commercial or reading something and pretty soon your nose is dripping? Or when you're really crying, nose is definitely dripping. So that's because those tears go right to the nose. Some babies are born with blocked tear ducts. And what happens, instead of having a natural flow and drainage, these are blocked and matter builds up and you don't have that nice windshield wiping cleansing of the eye. And one of my kids had this as a baby, and he'd wake up in the morning and his eyes would be all crusted shut, and we'd have to take a warm washcloth and dissolve all that matter away. And then the way to help a blocked tear duct is with a clean finger is to massage gently down to open up that sac and that duct, because some babies are just a little slow to develop right after birth, and then they're fine by 2-3 months, but initially it's a little bit of a challenge. So that's the sac where it collects, and then the duct takes it to the nose. And then the conjunctiva is, it's hard to see here in this, but the inside layer. If I pulled this eyelid down and showed you the red shiny inner lining of the eyelid, that's the conjunctiva. So it's a membrane that lines the inside of the eye. And here we can see it a little bit here, this little red and pink here, and we can see it here, but if I literally pull the eyelid down, that's the conjunctiva. And you've heard of conjunctivitis maybe before? That's the fancy name for pink eye. So I've had people ask me, because I'm a nurse and a mom, they'll say, I think I have pink eye. And I'll say, show me your lower, pull your lower lid down and show me the inside of your eye. And if it looks really red, compare it to someone else, and if it looks a lot redder, that's conjunctivitis. And that is somewhat contagious, but not as contagious as we think. It's contagious with kids in like daycare because they're touching their toys and they're touching their eyes, picking their nose, going back and forth, and it's just, a lot of, mess. But actually it's not very contagious. So if you have pink eye, you shouldn't say, I'm not coming to class today because I have pink eye. We'll be okay. You should come to class if you can see, right? Just wash your hands. Don't touch your eyes while you're in class. And what's funny is I learned as a teacher, it took me, maybe 6 times for me to figure this out. Every semester during final exams, I would develop pink eye here at Western. Why do you think that is? So I'm finally like, okay, stop it. Be smarter. Why do you think I was developing pink eye every semester during finals? Yeah. Yep, touching student papers, then itching my eye, touching student papers, and the #1 cause of pink eye is E. coli. So people have germs on their fingers from maybe going to the bathroom and not wiping and then touching their test paper, and then I'm grading that paper, picking up those bacteria, and then touching my eye. So I finally said, that's enough of that. I have hand sanitizer in my office, and I use it every time I come back to my office and throughout grading papers. I don't grade papers at the kitchen table anymore. I used to do that. Don't do that anymore. Especially when I taught micro lab. Very bad idea to grade micro lab papers when they're writing papers in the germy laboratory environment. So conjunctivitis, easily treatable with an eye drop, but you got to get an eye drop, take care of it, and not very contagious among adults, so not a big deal. But with kids, they tell you to keep them on a daycare until they've been on eye drops for 24 hours. Especially little kids, they're going to mix germs around. Okay, so then moving into the parts of the eyeball itself. So you have your eye model, and then we've got this side view diagram, which is from your textbook, and it's really good showing the layers of the eye, because you will see on a lab exam not only just the model with the different layers of the eye, but you'll also see this side view diagram. So working from the outside in, we have these 3 layers. The outer fibrous layer is called the sclera. So if I go all the way around, I can see the sclera comes all the way to the front, but then it's modified in the front and becomes transparent here. And we call this the window to the eye because it's transparent. It's the first thing that light has to pass through. So the white portion is called the sclera, and then where it becomes transparent in the front, this is called the cornea. So in this model here, the cornea, the sclera is the white, correct? And then we have, so the white is the sclera, and this window here on the outside is the cornea. So that's what that layer is, that outer layer, but it's modified. So the cornea is attached to the sclera. It's continuous with the sclera. And then we have the next layer, this dark layer on the outside, or in the middle I should say. It's called the choroid layer. So it's dark purple. And going back to our layers here, the choroid is shown in blue, or not blue, in red, sorry, in red here. This is the choroid layer. So looking at a 3D model, it's this dark purple layer right here. And in the layers, it's the red. So it has a lot of blood vessels associated with it. So if you look at your model and you take off that top layer, you'll see the blood vessels lying over the choroid. So it's very vascular. And this is dark in its appearance because it prevents scattering of light throughout the eye. But it's very vascular. It's the choroid. And then the inner layer of the eye is the retina. So here, this yellow layer is the retina, and it has a lot of sensory receptors on the back because light enters the eye and strikes the back of the retina to stimulate neurons found there to create an image in the brain as action potentials fire off at the back of the retina and exit the back of the eye via the optic nerve. So this is the optic nerve here. So if we look at this model here, we can see the choroid is this purple layer, right? The inside orange layer inside the eye is the retina. So the side view, it's this whole inner yellow layer, and in the eye model itself, it's the orange layer in the back. And this would be the optic nerve coming out the back. So in looking at other structures then, we have 2 circular muscles that are kind of glued to each other back to back. So looking at a front view, the hole in the eye is the pupil. So when you look at somebody's eyes and you see that black circle in the center, that's basically an open hole into their head, and it's dark, right? Because there's no light coming from the inside. It only comes from the outside. So that's just a hole into the eye. Around that, what controls the size of the pupil is the colored muscle of the eye, and it's called the iris. Now, some iris muscle has a lot of melanin, so those people have brown eyes. And some have very little melanin, and that's blue eyes. No melanin you're going to see the blood vessels in the back of the eye. And what color is their iris going to look like if there's no melanin to absorb or reflect light? Red, yeah. So pink eyes, right? So when you see rabbits that are white with pink eyes, that's no melanin in the fur and no melanin in the iris as well. So that's what that is. You're just seeing the blood in the back of the eyes. And when you take a picture of somebody and you see red eye, remember we used to have red eye problems before we had the nice cameras we have on our phones now? That red eye you see in the pupil, you're just illuminating the blood vessels on the back of the retina. So when a doctor looks into your eyes, he's looking at the back of your retina for a nice pink, solid blood vessel, vascular sheet, showing that you've got good blood supply in the back of your retina. But if a person has diabetes, which is damaging, like I said, to blood vessels and nerves, sometimes you're going to see splotches in the back of the retina where some of the capillaries have died and their vision is affected. So that's the iris with the pupil. And then if we look at the back side, we open up this eye model. So we're just basically taking this and opening it up and looking at the inside. We have the ciliary body, which is this round muscle. So it's, again, back to back with the iris. So we've got the blue iris is on the other side of this. So this is the ciliary body. And what sits in here, right here, in this little grooved spot here, is the lens. So the ciliary body is in charge of changing the shape of the lens for long distance or close vision. So this ciliary body contracts and thickens the lens when we're looking at something up close. And if you look at most doctors, lawyers, judges, people that spend a lot of time reading up close for school, so not only to prepare for their job, but also in their job, they're doing a lot of up-close reading. That wears out those muscles for thickening the lens, and as a result, a lot of them require glasses. And some of you wear glasses just because you inherited weak eyes or an oddly shaped eyeball or lens from your parents, so you wear glasses for that reason. But they can fatigue over time. And as we age, these muscles get weaker over time. And what do you see like grandma and grandpa or maybe even your parents do when they're reading? Don't they take the thing and hold it way out at arm's length? Wait, what does that say? That's because the muscles for close-up vision weaken and don't work anymore. And that's when people get their bifocals or where are my readers, right? I'm in my upper 40s. I have a pair of readers when I'm trying to, just read casually in bed. Or sometimes I'm finding when I'm at my desk, I have to sit up real tall to read the book. And I'm like, okay, this is a problem. So you just I bought mine at the dollar store. It's the cheapest place to go. But it's a fact of life. Everybody's going to get there. Those muscles weaken, as you get into your 40s and 50s. Some sooner, right? Some of you wear glasses already, but it's inevitable for most of us. So then we talked about that. Now on the back of the retina are some special structures you need to know. So there's this kind of brown circle. See that small brown circle on the back there? That is called the macula lutea. Macula lutea. So it's like it's yellowish in color. That's where it gets the lutea name, but macula lutea. So it has a large cluster of nerve cells for vision. So photoreceptors, we call those, the sensory receptors of a neuron carrying light information. And you're going to learn when you take your special senses exams, they're called rods and cones, these neurons on the back of our retina. So anyway, they're clustered here in the macula lutea. And then smack in the center, kind of like the bullseye, if the macula lutea is a target, smack in the center of it, it's hard to see until I zoom in a little closer here. See that dark spot in the center there? Right, smack in the center is a dark spot. That's called the fovea centralis. So if we can properly focus light on the macula lutea, great, we're going to get some good sharp vision. But if we get it right on the fovea centralis, we have our sharpest vision. So that's what, if you have glasses or need glasses because of weak muscles or irregularly shaped lens or a football-shaped eyeball, those are all different conditions. Glasses correct that light as it enters and bends it in the right direction to get it on that fovea centralis. But some people have a condition called macular degeneration, if you've ever heard of that before. And that is damage to the neurons in the macula lutea. So as a result, they can lose their vision very quickly, and can be a very serious condition for some people. Other people, it's very slow onset, very slow to get worse, and they just kind of deal with it as they age. But that's the macula lutea. And then the optic disc is this region in front of the optic nerve where there are no photoreceptors because we have all these axons exiting the eye here, and we have blood vessels as well because we know nerves need a good blood supply. So that's the optic disc, this space right in front of the optic nerve on the back of the retina where there are no photoreceptors. It's called the anatomical blind spot. It's not a blind spot like when you're driving and you can't see, you know, when your peripheral vision kind of goes on the side. That's a different kind of blind spot. But the anatomical blind spot is right over the front of the optic nerve. And some people develop a condition where they can't see well, and it's called optic neuritis, and that's where the optic nerve becomes inflamed. And there's a number of conditions for that. Multiple sclerosis is one of them. But then that needs to be treated, of course, so it doesn't get worse. Okay, and then there's fluids in the eye. So if we go back to this picture here, I'll back out a little bit. There's chambers that hold the fluid, and then we name the fluid. So the first chamber that you need to know is the anterior segment, is what we call it, or anterior cavity. And it contains a real watery fluid. So where do we find this? It's between the cornea and the lens. There's this small amount of fluid here. And it's consistently drained away, so the pressure over the lens and the cornea is in an ideal amount. When there's not enough drainage, there's too much pressure in there, we call it intraocular pressure, and that's what glaucoma is when people have too much pressure in the aqueous, or in the anterior segment. And the name of the fluid is the aqueous humor. So the aqueous humor is a watery fluid that is found in the anterior segment. So they both start with an A, anterior segment, aqueous humor. Those two go together. They're real watery. And when you dissect your sheep eye, you're going to see the little water in the bottom of your tray, and that came from there. So you won't really see that when you're dissecting, other than the water. But you will notice this fluid that's found in the posterior segment, so this large segment here from the lens to the retina. It's kind of a cloudy white in this diagram. That is called the posterior segment, so the whole cavity, posterior segment. And the gel-like, it's almost like a jello that's not quite ready to be served yet. It's called the vitreous humor. So it is kind of semi-solid in a way. You'll see that in your tray. It'll be a little blob sitting there in a cluster in your tray when we dissect. And that allows some bending of light. So it's important to bend light as it enters on the right spot of the retina. And it also gives shape to the eye. It fills up that space. Some people get floaters as they age or even when they're young. Some of those can be scratches on the cornea, and some are in these fluids themselves, and little proteins start to condense, and then they see these little gray squiggly lines. And you know you have a floater if you stop, like you look back and forth and then you stop, like look at a white wall, stop, and then if that floater keeps moving, you know it's in the fluid of your eye and it's not on the lens or on the cornea. So you just look back and forth and watch it. I have a lot of floaters. I've had them since I was a kid. So some people have them more than others. So those are the fluids of the eye. The aqueous humor here, vitreous humor filling this space here. And again, you've got the cornea first. So don't call that the lens. Some people call that the lens. It's not the lens. And then you have the lens here. So the ciliary body is this muscle that we looked at that has kind of a scalloped arrangement. It looks like a mushroom kind of on the back side when you're looking on the inside. But in a side view, the ciliary body is here, this muscle. Sorry, not this muscle. This thick muscle here with the little strings attached. This is the ciliary body, and it controls the shape of the lens. So just think of the ciliary body is in charge of the lens, and the retina is the other muscle, and it's in charge of the size of the pupil. So if too much light comes in, the retina constricts and shuts down that pupil and makes it very small. And if there's not enough light, the retina relax, or the lens relax. I can't talk. The iris relaxes and makes the pupil really large. So the iris controls the size of the pupil. Constricts if there's too much light, dilates that pupil if there's not enough light to ensure that we can see well. Yes?
So where's the aqueous humor and the vitreous humor?
The aqueous humor is in front. It's in this space right here between the cornea and the lens is the aqueous, real watery, and this huge amount of kind of jelly-like, gel-like substance here. This is the vitreous humor. So, and this is the anterior segment. This is the posterior segment. So anterior, aqueous humor, posterior, vitreous humor. Okay? All right, so let's take a little time and have you review the structures of the eye, and then we'll start on the ear. I'm going to pass out the sheep eye. So here's that labeled diagram of the different parts of the sheep eye. I just kind of stole it off the internet, so you can look at those parts. And then I do have a separate video that I just recorded for the sheep eye, so if you need to review that, you definitely should. If you didn't actually do the sheep eye dissection, you should definitely watch the video so you can see all the parts. Now we're going to talk about the ear. So there is a picture of an ear model here. Start with that. So we are on page 19 in the lab packet. So starting off looking at the auricle or the pinna, that's just a fancy name for the actual external ear itself. So this is called the auricle or the pinna. And that is basically acts like a funnel to funnel sound into the ear. And then the external auditory meatus, remember we studied this when we were looking at the bones of the skull. This was part of the temporal bone, remember, that hole. Well, it's lined, it's a canal, and it's lined with a mucous membrane, and instead of secreting mucus, which would be really gross coming out of our ears, it's lined with wax. So they're modified glands, modified sweat glands that secrete mucus, or not mucus, secrete wax, which we call cerumen. C-E-R-U-M-E-N, cerumen is the wax, and that helps trap debris that comes into the ear and helps protect that delicate mucous membrane that's underneath that waxy layer. So is it wise for people to say, I have clean and squeaky ears, I have no wax in my ears? Is that a good thing? No, that can cause inflammation and damage to that delicate mucous membrane. So we need some amount of wax in our ears. Now, can people get a buildup of too much wax? Definitely. And they might need to get it cleaned out if they go to the doctor. But people should not be digging in their ears and cleaning all the wax out and buying those kits you can get at Walgreens unless you have a diagnosed buildup of excess wax and you can't hear, then obviously you have a problem. But otherwise, we should leave that alone, let the ear do what it's meant to do. It secretes a moderate amount of wax to protect the mucous membrane. So that's the external ear. So when someone has otitis, oto means ear, otitis means inflammation of the ear. There's otitis media, which is inflammation and infection of the middle ear, and then there's otitis externa, which is infection, inflammation of the external ear. So if someone has swimmer's ear, for example, this mucous membrane gets very inflamed. So my kids get this when they are doing a lot of summer swimming. There's a lot of moisture inside that ear canal, and if it doesn't drain out, bacteria from the water they were swimming in, even swimming pools will have bacteria and cause an external or outer ear infection. So we can easily treat that with drops because you can get to it, right? It's right exposed to the external, air. We can just put some drops in there. And to prevent it, what I've done now is my kids are going to wear earplugs when they're swimming, and also when they're done, there's a drying agent. It's a mixture of hydrogen peroxide, alcohol, is it vinegar? I think so. There's like 3 different combinations. People that live in Florida that do a lot of swimming, everybody has a pool, there's a lot of humidity, that's a regular routine for them is to put these eardrops in. So that's an external ear infection. And the way to diagnose an external ear infection from a middle ear infection is when you pull on the lobe of the ear. It's very painful if someone has an external ear infection because of that membrane being inflamed. So you yank on the earlobe and it's really painful. So that's the outer ear. And then there's a eardrum that we know, we've heard that word before, but it's in the clinical environment, we call this the tympanic membrane. So that is the doorway that separates, but it doesn't open. So it's just basically a membrane that divides the external ear here from the middle ear, which is here. So this whole space right here is called the tympanic cavity, this whole space. So there's 3 ear bones found in the tympanic cavity. One is attached directly to the tympanic membrane, and that is called the malleus. And someone thought that it looked like a mallet, so that's why it was called the malleus. So this first one here is the malleus. And then the middle bone is the incus. And some people thought that that looked like an anvil, like what you would see in like a hardware workshop or stirrup appearance. So the malleus is attached to the tympanic membrane. The stapes is attached to the inner ear structure. We'll talk about that. And the incus is in the middle. So that's what how I remembered it when I was studying this, is incus starts with an I and it's in the middle, which has an I in it. So the 3 bones work together, so when the tympanic membrane vibrates as sound strikes it, it sets these bones in motion, and this the stapes pushes on the membrane of the inner ear and sets the fluids in motion in the inner ear.
You're not showing it.
Thank you. So to have good vibration going to the inner ear, we have to have a tympanic membrane that's intact, right? So this membrane has to be intact and not have a hole in it from a ruptured eardrum, right? And there can't be a lot of fluid in here. So when someone has otitis media, they have infection of the fluids in the middle ear. And what causes that? Well, typically a head cold. After it's been hanging around a while, it starts to cause fluid to build up and inflammation in that middle ear. And some kids have narrow, horizontally oriented eustachian tubes or auditory tube. This is called the auditory tube. And normally this keeps the fluid and the pressure of the middle ear in balance, so we don't have pain and discomfort and hearing issues. Every time you swallow, can you hear the clicking in your ear? That's because the auditory tube, every time you swallow, opens up and closes, and you equalize that pressure. When you yawn, in the middle of a yawn, and if you're taking a deep breath in, can you kind of hear yourself breathing through your ears? Because again, when you yawn, you're opening up that eustachian tube. And what do you do if you're going up in a plane and you feel that pressure building up in the middle ear? Yawning helps break that up. But if you have a really bad cold, and there's some fluid there, and those auditory tubes are a little bit inflamed with fluid too, or mucus, then you can't clear that pressure out, and it's very painful. So parents who bring young babies on the plane and that young baby is fighting a cold, that can be really painful for that baby. So what's the best thing to do is when they're taking off or landing, get babies swallowing a lot. So maybe it would be a good time to feed baby on takeoff and landing. But if baby doesn't want to sit still, because takeoff and landing is kind of bizarre feeling, right? It can be upsetting to a young child. What I did with my kids is the little dum-dum suckers. You know, you get free at the bank and all that. I always had a stash of those, and I would never give it to the baby so they would choke on it. But I would hold the stick, and every baby will take a dum-dum sucker no matter what's going on, because they're a treat and they taste great. So we give dum-dum suckers right after injections, you know, at the doctor immunizations, and takeoff and landing, and they typically didn't have a problem because they're doing all that swallowing, and that's opening up that eustachian tube. So that drains the middle ear, and as we get bigger, this tube opens up, gets more vertical, does its job draining, and people tend to not have as many ear infections, you know, as they get into teenagehood versus young children. And some people have such a problem with ear infections that they have to get tubes, ear tubes put in, and that's where they poke a little hole right here in the tympanic membrane. So if there's fluid in here from an infection, it can drain out, and you can treat that middle ear infection with ear drops, because the drops can get through the membrane if there's a hole there. It's a little plastic tube, little rubber tube actually, and as the child grows, the tube loosens and falls out. And some of my kids had to get ear tubes, and I would find this little purple tube on the pillow with a bunch of wax around it that they fell apart, fell out while they were napping. So it's a wonderful thing. And what I discovered with my kids that did have tubes, sometimes just the putting of the tube in there, because when they put that tube in there, before they put the tube in, they put a little device in there and suck all that nasty, yucky fluid that's been sitting in there for a long time, and they clean out that middle ear. Just that process alone was enough to set my kids on a path of no more ear infections. So you really have to be an advocate nowadays for ear tubes in your kids, because doctors are busy and they're not always looking up how many times you've been in, and they'll just keep prescribing antibiotics. And those antibiotics you give your child by mouth are going through their whole system. So it's killing the natural bacteria in the gut, so it sets some kids up for diarrhea. It kills the natural bacteria in the genital area, so boy and girl babies end up with these really bad diaper rashes that are caused by overgrowth of yeast in the diaper area because you killed the bacteria. And I didn't learn that until many kids later, that the best treatment for a diaper rash while a kid is on antibiotics, what type of cream should you be putting down there? Antifungal creams, yeah, because that's what's causing that diaper rash. And those diaper rashes are vicious. When kids are on antibiotics, I had my kids literally with open sores bleeding on their bottoms until we figured it out. Unfortunately, our doctors didn't make us aware of that until way late in the game. So using an antifungal cream helped that. So that's the middle ear. And then the inner ear is this kind of funny looking structure here. It looks kind of like a snail with a funny head. Underneath the stapes is a thin membrane, and that membrane is called the oval window. So if I look at underneath the stapes on this on this inner ear structure is the stapes, the oval window is underneath the stapes. So the oval window is underneath the stapes. And then if I turn that ear model and look at the underside, there's a thin round window. It's completely round. So it's easy to see. The oval window is oval. It'd be underneath the stapes, which has an oval end to it. So underneath that is the oval window, and this is the round window. So these windows are like trampolines. So if I have a sound pressure wave setting those bones in motion in the middle ear, so you have, a vibration striking the tympanic membrane, these ear bones are in motion, the oval window is pushed downward and the round window is pushed outward. So the oval window sets the fluid in motion and the round window kind of dampens the sound. So it doesn't get too much motion in the middle ear and you don't get too much sound, too loud of a sound. So the oval window and the round window work together by vibrating in opposite directions to balance out the sound motion or the vibration of the fluid inside this inner ear. So this side of the inner ear is for balance, and these are called the semicircular canals. So there's 3 half-rounded structures on the end here. So that's what these are here. Those are called the semicircular canals. And there's fluids in there and little suspended crystals that keep our balance in check. Now, if you have a bad head injury or certain viruses can offset these fluids and cause dizziness. We call dizziness in the clinical environment, we call that vertigo. Some people can go to a chiropractor, or at Gunderson, when my son had a serious sledding injury and had a bad head injury as a result of it, he went to this physical therapist who did vestibular therapy, and she had him lay down and sit up, and he wore these special goggles, and she would watch his eye movements, and she could get those fluids in balance again by doing certain motions. And she said she had people that had car sickness all the time, they couldn't go on any rides for 20 years, came and saw her and she corrected it. So if you know someone who really struggles with vertigo and dizziness, it might be worth checking out if they're a candidate for this vestibular therapy, because it did wonders for my son. He kept throwing up. He couldn't get out of the hospital because anytime he sat up, he would throw up. So when he went to the vestibular therapy, it corrected that and he felt a lot better. So this kind of middle region that connects the end of the inner ear to the semicircular canals, we call this middle region the vestibule. So that's where the oval window is. It's on the vestibule. It's on this kind of central portion, like the body of the snail. That's the vestibule. And then the circular kind of shell, snail shell looking structure, that's called the cochlea. And then information about balance and hearing. So this is where the hearing, the sound receptors are in the ear that goes to the, remember that goes to the temporal lobe. This nerve carries balance and vision information, not vision, balance and hearing information. It's called the vestibulocochlear nerve. And it carries that information to the temporal lobe. So vestibulocochlear nerve. So there is out on Blackboard, there's a nice tutorial of the ear. So I recommend that you look at that. Let me get back to where we're, so in our lab 7 here, there's a nice ear tutorial that you can look at. You can kind of hover over and point to the different parts of the ear. So it's interactive. You can just kind of hover over and look, goes over all the different parts. So I recommend, take advantage of that. It's a good way to prepare for the lab exam.